Hi everybody and welcome to today's presentation on UX best practices for bidirectional languages. By far my favorite topic. In today's presentation, we will be going over what I think makes a great user experience for speakers of bidirectional languages. Let's start off with a quick intro. My name is Gilad Almosnino. I live in North Israel in a small town called Kiryat Tivon. I'm a software internationalization consultant and also chairman of the Hebrew Supporting Computerized System Committee at the Standard Institute of Israel, where we are working to standardize user experiences for BiDi languages. In the past, I worked at Microsoft for about 20 years in various positions, including international quality assurance and international program management on products such as Windows, Xbox, and Surface. I always like to start off by providing a quick market overview. BiDi market consists of 27 countries, 450 million speakers, and 4 primary languages that span from Morocco to India. When it comes to bidirectional languages, there are 2 elements that present challenges to designers and developers. The first is the fact that Arabic, Hebrew, and Farsi require bidirectional text support, the ability to read and write from right to left, but also read and write from left to right. The second challenge has to do with the UI layout. The UI layout normally has to be adjusted so that it flows from right to left. Often this is called UI mirroring. There are 3 elements that come together to produce a great BiDi user experience. The first one is regional support. That has to do with calendars and native digits. The second element is text, and that has to do with BiDi text support and automatic alignment and layout properties. The third element is UI, and that has to do with localization and user experience mirroring. All of these elements are going to be discussed in detail later in the presentation. We'll start off with regional support. When it comes to calendars, BiDi markets require both Gregorian and lunar calendar support. If you're deploying on top of any major operating system, these type of calendars are already available as part of the standard controls. In addition, it's worth mentioning that it's very important to make sure that these calendars flow from right to left. The first day of the week on any of these calendars is going to be Sunday, and weekends are going to fall on Friday and Saturday. Most up-to-date locale information can be found as part of Unicode's CLDR repository, and I encourage you to go visit there if you haven't had a chance to take a peek at what's going on there. The second element in regional support has to do with digits. Arabic, Persian, and Urdu require that numerals display using native digits. Not a lot of people know this, but English actually uses Western Arabic digits. They inherited their digits from Arabic. Arabic has moved to Eastern Arabic digits, and as you can see from the table to the left, the representation of digits is quite different. The best example I could find of this is a cash machine keypad, and as you can see to the right, the keys have both Western Arabic digits and Eastern Arabic digits so that any user that approaches the machine is able to use it properly. In this next section, I'll discuss bidirectional text handling, how and when to support bidirectional text layout. Even if you don't have UI mirroring enabled or don't plan to enable UI mirroring, this is a great section for you to understand what are the requirements for displaying BiDi text correctly. Before we dive into this section, I wanted to go over a couple of terms that I'm going to be using throughout the presentation. The first one is BiDi, and it stands for bidirectional text support, both input and display. The second one is text alignment. That's the horizontal positioning of text. The third one is text layout, and that has to do with the text reading order, and I'll describe that later in the presentation. And the last one is LTR and RTL. They stand for left to right and right to left. Let's start off with the basics. BiDi languages flow from right to left. That's pretty easy, right? One of the most common scenarios is for an English term to be embedded inside a BiDi sentence. And so in that case, the reader is going to start reading from the right, but when they get to the English term, or in this case, I think it's a Swedish term because this is the IKEA catalog, they will be reading the word bästa from left to right. And then after they completed reading the word bästa, which is highlighted here in red, they will continue reading from right to left until the end of the sentence. You're probably wondering how all this comes together to create a great user experience. Well, I thought a notification center is a great example that can be used to help you understand the different requirements for bidirectional languages in terms of layout and alignment. Notification centers are awesome because they often display user-generated content in different languages. And so for BiDi languages, there's a requirement for built-in flexibility to adjust the text alignment and layout based on the notification language. So when displaying BiDi language notification, the text has to be right aligned. And when displaying English or other left to right languages, the notification has to be left aligned. And I put together an example here, and you can see we have a left to right user layout here, English, and then we have a left to right notification in English, and that notification is left aligned. Right below it, you'll find a Hebrew notification, and that notification is actually right to left. If the UI was mirrored, the same principles apply. So an English notification would retain its left to right orientation or layout, and Hebrew, Arabic, or Farsi, any other BiDi language notification would retain their right to left alignment and layout. So as I showed you in the previous slide, alignment and reading order have a huge impact on readability. And I did want to show an example of what happens when you get the alignment incorrect. And so I have here a screenshot from the Xbox Live app that's shipped with Windows 10. And as you can see, the English notifications that have multiple lines are aligned incorrectly. They're right aligned. And so it makes for a very poor user experience and deteriorated readability for users. So regardless of which platform you choose to deploy on, the good news is there's BiDi support that enables you to automatically detect and adjust BiDi text properties automatically. And so in some cases you do have to enable it because it's not turned on by default, but it is highly recommended that you do go ahead and enable that functionality so that you're able to display BiDi content correctly. The algorithm responsible for detecting and applying directionality to strings works in a really simple way. What it does basically is scan the first few characters of a string and makes a determination on directionality. And in most cases that works really well, but in some cases it doesn't. And so I did want to produce one example that shows you how a string like that might look like. And so what we have here is an English string that basically says Haifa and Jerusalem are city names in Hebrew. As you might have noticed, the word Haifa and the word Jerusalem are written in Hebrew. And what happens is the algorithm is going to think that that is a right to left string, when in reality it's actually an English string. And so the results are going to be a string with broken reading order. And this is what we have here. And you can see that the words have been scrambled and that the reading order is completely different than what you have on top. There's different ways of handling that, and we're going to cover that in the next slide with Unicode BiDi control characters. Unicode has a set of BiDi control characters, and these control characters basically allow you to let the rendering engine know how exactly you'd like a string to lay out. And so the first set of characters in the set are called the right to left or left to right embedding. And they basically allow you to set their directionality and layout on an entire string or a sentence.
If you find that within that sentence you have some problems with embedded text in a different language, you might want to isolate that text, and the Unicode control characters provide you with that option using the right to left or left to right marks, and they isolate text within a sentence. The last control character covered here is the pop directional formatting, and that basically neutralizes any direction that was set by previously inserted control characters. Text trimming is one of the last items we're going to be discussing as part of this section. Text trimming is actually derived often off directionality. So if you set your string directionality correctly, your trimming should work just fine. But you do want to make sure that you're not accidentally trimming the leading edge of a string, because that causes deteriorated readability across the UI, especially under mixed language scenarios. The last slide is about text input, and in most modern operating systems, when the user enters text, the operating system will auto-detect what that text is and make appropriate adjustments for direction. And so if you're inputting English text, it will left align, and if you're inputting Hebrew text, for example, it would right align. You do need to pay attention to the positioning of certain UI elements to ensure overlapping does not occur while the text is adjusted. The last section in the presentation is about UI mirroring, and I'll discuss when and how to reorient UI layout for BiDi languages. One of the most common questions I get is when should I apply UI mirroring? Should I localize my strings and maybe later on apply UI mirroring, or should I mirror the UI and then later localize my strings? It's kind of a chicken and egg thing, right? And so we are here in the Middle East, and I kind of replaced the chicken and the egg with pita and hummus. Which one came first? But there are some guidelines that are very simple for you to understand whether or not you should apply UI mirroring or not. And so always mirror UI if you localize UI strings. And avoid localizing UI strings if mirroring is not enabled, because the experience that produces is really not something that's easy for the user to digest. So what are the benefits of mirroring the UI? Well, simply put, it allows the information to be presented in a pattern already familiar to users. The reading pattern always starts from the top right and advances to the left. In this sample here, you could see the left to right UI, the English UI. This is a billing workflow. And as you can see, I have the back button here pointing to the left, and the billing workflow here starts from the left and continues to the right. And on the opposite side, you have the right to left UI, the mirrored UI. And as you can see, I've made an adjustment here for the back button, and also made sure that the flow of the billing process is adjusted so that it flows from right to left. The general rule of thumb for mirroring icons keys off directionality. The back and forward navigation buttons are the most significant in terms of UI mirroring. They are adjusted so that the back button is pointing to the right and the forward button is pointing to the left. Similar application is appropriate for undo and redo buttons. That being said, most icons, as long as their directionality is agnostic, do not have to be mirrored. Media controls are one of the few exceptions when it comes to mirroring. Media controls actually inherit their arrangement from audio and video hardware such as VCRs and cassette players and compact discs. What happened is basically the market got used to having media controls display in a certain way, and so you don't want to mirror those controls under any circumstance, because it just confuses users. So the playback and other related buttons retain their original left to right arrangement, and if you have a progress bar, it also should advance from left to right. A horizontal progress bar is expected to flow from right to left, to progress from right to left. The only exception to that is what we discussed in the previous slide, which is media controls. Circular progress indicators derive their directionality off clocks, analog clocks, and so they are always expected to turn clockwise, even on BiDi systems. There are a few differences between Hebrew and Arabic. In terms of percent symbol positioning, Arabic requires that the percent symbol is positioned on the left, where Hebrew is similar to English and requires that the percent symbol is positioned on the right. And as you can see here in this illustration, we have on the left here, we have the Hebrew circular progress indicator with the percent symbol to the right. And you have the right next to it, the Arabic circular progress indicator using Eastern Arabic digits and the percent symbol positioned on the left. When it comes to button layouts, it makes a lot of sense to mirror buttons so that the off position is on the right and the on position is on the left. The second thing around buttons is check marks, and absolutely do not mirror check marks. That never looks good and makes absolutely no sense to users. Horizontal sliders are often mirrored in most cases, and that basically means that the minimum range of the slider is going to be on the right, and the maximum range of the slider is going to be on the left. The only exception to that are horizontal sound volume sliders, and as you can see here, those remain unmirrored, and that's because they inherit their directionality from media controls. One way to neutralize directionality with sound volume controls is to have them laid out in a vertical fashion rather than horizontal fashion. Both rating and page selectors are often mirrored. That basically means that in case of a rating selector, the lowest rating is going to be on the right and the highest rating is going to be on the left. With page selectors, you're going to have to reorient the positioning of the individual page numbers, but also that's going to flow from right to left with the lowest number page on the right and the highest number page on the left. In addition, if you're localizing for languages such as Arabic, Urdu, or Farsi, you want to make sure that those page numbers are displayed using native digits. The last slide in this presentation has to do with touch gestures, and if you're using standardized controls, most likely you're not going to run into any issues, but sometimes it's the case where when you apply UI mirroring, touch gestures will break. And what I mean by break is the user might swipe to the left and what the application sees is a swipe to the right. Similar experience happens under inking. So just make sure to thoroughly test your touch gestures once you mirror your UI so that they are working appropriately. So that was my presentation on building a great BiDi user experience. I hope it helps you build a terrific experience for BiDi users across the region. If you need help, do feel free to reach out to me via email or LinkedIn. Both addresses are available here. And also, if you haven't had a chance to check out my article on LinkedIn for BiDi best practices, you're welcome to check that out. And I hope you enjoyed the presentation. Thanks.